In this video, we will be talking about the moon, its phases, and its motions relative to the Earth. So first of all, just like the planets orbit in an elliptical shape, the moon also orbits the Earth in an elliptical shape. So the point at which the moon is closer to the Earth in its orbit, right here, that is known as perigee. And the point where it is the farthest from Earth in its orbit is apogee. And this is why the moon appears to be larger or smaller during certain times in its orbit. All right, so we talked about the sidereal month or sidereal day when we're talking about the Earth's orbit or revolution around the sun. The same thing happens when the moon is orbiting the Earth. The synodic month is the amount of time it takes the moon to go through all of its phases, and that's 29.5 days. However, it does not take that long to revolve around the Earth. If we look at this diagram, the amount of time it takes the moon to orbit 360 degrees is only 27 1/4 day. But because the Earth is also moving around the sun while the moon is orbiting around the Earth, the moon has to go just a little bit further to maintain that same line in reference to the sun. So this is called the sidereal month. Have you ever noticed how we always see the same side of the moon? The reason is because as the moon is revolving around the Earth, it is rotating on its own axis at the exact same speed. It takes 23 1/3 days. So if you look at the picture or the diagram on the left, you can see if you watch just the moon, you can see that it is spinning on its axis, like if we were to take the Earth out of the picture. To visualize that a little bit better, on the right I've given you an animation of a quarter and the penny. So if you imagine that the penny is the moon and Abe Lincoln's head is the side of the moon that we always see, you can see how it changes. When it's here, he's upright, and when he's here, he's upside down. So that shows us that yes, that penny is in fact rotating while it's revolving. So no matter where you are on Earth, you're always going to see that same side of the moon. All right, so what we see depends on the light that is reflected by the sun. So in this diagram, if we imagine that the sun is sitting right here, the pictures that are depicted here are what we can see from the Earth. So in this position, the new moon, the sun is being reflected off the opposite side of the moon, so we cannot see it. And then as the phases get larger, that is known as waxing. So we have our waxing crescent, our first quarter, waxing gibbous, until we have our full moon. And then this half of our moon phases are known as waning, which means getting smaller. Waning gibbous, third quarter, and waning crescent. All right, so there are two types of eclipse that we modeled in class. The first is a solar eclipse, and that is when the moon is positioned directly between the sun and the Earth. So it actually creates a shadow on the Earth right around the equator. So if you look at the animation on the left, you can see the shadow of the moon moving across the sun. When it's directly in front of the sun, we can actually see the sun's atmosphere. Okay, and our second type of eclipse is a lunar eclipse, and that is when the moon passes through Earth's shadow. So overnight, it will start here, and as it moves through, you could see the shadow of the Earth. Now, when it's directly behind the Earth, it almost has a red glow to it, as you can see that animation, and that has to do with the sun's rays as they are bent through Earth's atmosphere. So it gives off that red glow. And that's it for the moon motions.